Hi everyone! In this video we will solve a quadratic with factoring and the square root property. Solve 4b squared plus 12b plus 9 equals negative 49. The left side of this equation actually follows a pattern. We have a perfect square. This is squared and this is also a perfect square. If we square root them, we get 2b and the square root of 9 is 3. Taking the middle sign is a plus, and the whole binomial is squared. To double check that, we can multiply 2b plus 3 times 2b plus 3 with the foiling method. 2b plus 3 and 2b plus 3. We end up with the first times the first. 2b times 2b is 4b squared. Outside gives us plus 6b. The inside is also plus 6b. And the last is 3 times 3, which is plus 9. Adding the like terms in the middle is 12b, and you can see that when we FOIL, we end up with the original problem here on the left side of the equation. For cleanliness sake, we're going to come over here. The left side then factored beautifully to 2b plus 3 quantity squared equals negative 49. To negate the square on the left side of the equation, we need to square root the square to negate it. Square rooting a square cancels out, so on the left side we end up with 2b plus 3, and we don't need any parentheses anymore because the entire thing isn't underneath the radical. On the right side, we must also do the square root property so that we keep the equation balanced. Whenever we square root something, we get a plus or a minus. However, in this situation, we have the square root of negative 49. Negative 49 is not a real number. This is an imaginary or a complex. If you simply need to know if it's imaginary or complex, you can stop at this point and just say that there is no solution. However, if you need to find that imaginary or complex number, you can continue following along with me. The square root of 49 is 7, and the square root of a negative 49 gives us I. So we end up with plus or minus 7i. Now we have two answers for the equation. So let's go ahead and we will break this into two equations, one with the positive 7i and one with the negative 7i. So we have 2b plus 3 equals the positive 7i. And 2b plus 3 equals the negative 7i. Now to continue solving, we want to isolate the variable, so we'll subtract 3 on both equations from both sides. On the left side, it will cancel on both equations, and so we're left with 2b equals negative 3 plus 7i for the first one, and 2b equals negative 3 minus 7i for the second one. And we keep the real part first and the imaginary or complex part second. Now to continue solving for b, we'll divide by 2 to negate the multiplication by 2 on both equations. So we'll divide by 2 on both sides. 2 divided by 2 cancels, so we're left with b equals negative 3 plus 7i divided by 2. And b equals negative 3 minus 7i divided by 2. These are both of the answers, and we could stop here, or we could separate those fractions so that the terms in the numerator are broken up with the same denominator. So we could also write this as negative 3 over 2 plus 7 over 2i, and let's do a comma here, negative 3 over 2 minus 7 over 2i. Either of these are acceptable for our answer, and now we're all done. And just as a reminder, you could also have gotten to the point where you wrote no real answer or no real solution. And now we're all done.